Okay, we'll be talking about determining the accuracy of your measurement. So we completed our graph, determined our slope, what our rise of our run is, wrote our workout. The slope was, the graph rose 44 grams, the run was 5 milliliters across, 44 divided by 5 was 8.8. That was our experimental density. We looked up different metals that had a density of about 8.8, and what we came up with is we think it's copper. So, I mean, copper is the same color, has a density very, very similar to that. The question is, how close are we? Were we within what would be considered human error? Is this acceptable error, or are we so far off that we have to chalk this up as some major mistakes that must have been made in the lab? By first glance, those numbers look pretty close together, so we need to see how close. You have to do what's called determining a percent error. Okay, or percent error, some people call them percent difference. I'm gonna use percent error right now. I'm kind of partial to that term. And what you do is you take your standard value or your actual value. You subtract your experimental value, so you get a difference. Experimental value. You do that first. You gotta get the difference. That's considered your error. Well, that difference, it really depends on what it's out of. So you take that difference and you divide it by what the actual was. And so then you'll see just how far off your error was from what the actual number was. And that ratio, that division, gives you a ratio that when you multiply by 100, gives you a percent error. So that's what we need to solve, okay? This is the percent error formula. You're given this formula. It's not something you have to memorize. But you take the actual density of 8.94. Oh, excuse me, this should be in absolute values, because if you're a little low, it's a negative, well, that's still considered a positive percent. You're just that many percent below. If it's a bigger number for the actual, then it's going to be a positive number because they're that many percent above. So make sure if by the absolute value just means make the final answer a positive. Okay, our actual value is 8.94. That's what I looked up. This number, and I don't want to write on my nice data table, or excuse me, lab report, but this number was given to me by, the internet, by source, by my textbook, by periodic table. I did not have this memorized. This is what I looked up, determined that that's what I think it is. My answer was 8.8. Then I'm going to divide it by the actual answer of 8.94 and multiply by 100. Okay, so I'm going to type that in the calculator. 8.94 minus 8.8. I had to hit equals because remember order operations with parentheses. You get 0.14. Divide that by 8.94 and then multiply by 100. And you come up with an answer of 1.56%. And we have what are known as two sig figs right here, two digits, measured numbers. So the 1.56% is going to round to 1.6%. Calculator told me 1.56, I'll round up to 1.6. A percent error of 1.6 is excellent. I did a great job on this lab. I plotted a best fit line that went through the average of the points. I determined its slope to be 8.8. I compared it to the standard value that I found online, and then determine my percent error, and I only have a 1.6%. So I can say with confidence, this element is copper.